Hey, it's Mr. Barr, and today we're going to do linear inequality models. Got my notebook, got my markers. My goal, I can create and use linear inequalities and graphs to model real-life situations. Why? Life is rarely equal. I want to be able to use the concept of greater than and less than to solve problems. Why do we care about any of this? Because it is useful in the real world. Most people get a loan when they buy a house. Loans cost money. There are fees and interest rates. Most people only have so much to spend on a house. Maybe they can't spend in total over $300,000. This is one big inequality problem. Today we'll look at a simplified version of real-life inequality problems. We already have a couple forms of an equation. We have the standard form as an equation, and we have the standard form as an inequality. And is everything we're doing today going to be standard form, standard form, standard form, standard form, standard form? Okay, it looks like everything we're doing today is in standard form. All right, so let's get this into our notes. Linear inequality models, and we're doing everything in standard form. So let's start with our notes, with our name. And our title is going to be Linear Inequality Models. And we're using standard form. Which is ax plus by equals c. But today it's going to be ax plus by is less than c. Now it could be greater than or equal to, but you get the idea. And for the most part, these are going to work out as like two distinct types of items. So this is usually like item 1. This will be item 2. And this usually is going to be the total for us. Item 1, item 2, and a total. When we do slope-intercept equations, we usually have a starting point and how it's changing. But for standard form, it's 2 items. So here we go. We have Joey. He's playing games at an arcade where the machines take tokens. He can afford to buy up to 65 tokens. Skee ball is 1 token. Pinball is 4 tokens. We can model this, and then we're going to graph it. So let's get into our notes. Pinball is, we'll call it dollars, okay? Pinball skee ball we'll use P for pinball games and S for skee ball games, and our total is 65. So let's model this. $4 times the number of pinball games I play. Hey, it's Mr. Best. Come on, Mr. Best. Hey, look, it's Mr. Best. Mr. Best, give us some wisdom, man.
I've got nothing left.
Best has nothing left. Okay, so I've got some wisdom. Ready?
Go for it.
Some people say the glass is half full. Some people say the glass is half empty. I'm just happy to have a glass.
Oh, there you go.
There we go. All right, I'm going to pause it and I'll come back to you in a second. And I am back. All right, so $4 times the number of pinball games I play plus $1 times the number of skee-ball games I play has to be less than or equal to $65 or tokens, however you're going to think about it. Now, could we graph this thing? Absolutely, we can graph this. It's standard form, so I'm going to graph it. Now I have to really think about the scale on this. So 4p equals 65, which means p equals 65 divided by 4. So p equals 16.25 and s equals 65. So if we set this up, so we'll make this axis right here. This will be pinball. This will be skee ball. Pinball has to get out to 16.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. 11, 12, 13, 14, 15, 16.25. So there we go. There's my pinball. And this guy, let's go up by tens. So 10, 20, 30, 40, 50, 65. And every point under here is a valid solution to this. These are all the different ways that our friend can play games. So he can do one pinball and 1, 2, 3, 4, and 50 skee balls. That's one way he could do it. He could go 1, 2, 3, 4. 1, 2, 3, 4, 5. He could play 5 pinballs and 10 skee balls. He could play 5 pinballs and 20 skee balls. All of these points are possible ways he could play the games. All of these points. Now, is this a possible one right here? No, because you can't play half a pinball game. You either spend the money or you don't. So we just modeled this. So here's another one. I'm going to model it for you. Tax purposes, so here's my total right here. And my two things I'm working with are a hospital and schools. So I can go 14,000 for a school plus $2,400,000. I'm just, those are zeros. Are you with me? Can I use the word K for 1,000 for a hospital? And they want to spend more than this amount, more than it, so greater than or equal to that much. Actually, more than, it would probably just be greater than, right? If they want to spend more than, greater than. Let's try another one. So she can spend up to $3,300. Paperback books cost $1. Hardbacks are 9. Okay, so 9x, 9 times the number of hardbacks, plus 1y, $1 times the number of paperbacks, has to be less than or equal to $3,300. Arlington is hosting a nationwide or citywide arts festival. They can have a big booth or a little booth, and they want to make at least this much money. So $48 times a little booth plus $86 times a big booth needs to be greater than or equal to $2,300. And we could graph this and find all the possible solutions. Actually, we will graph this one. Let me I'm going to switch it around here. It's going to be 86x, just because I like to have x come first, plus 48y equals that. So if I do mini equations, I'm going to do 2300 divided by 86. So x equals 26.7, y equals, dividing it by 48, it's pretty close to 48. So 48 times 48 is pretty close to that number. Okay, good. So let's graph this. Gonna really think about my scale here, trying to figure out how to make it fit on the paper. So we'll call this smalls. Let's see, x is, you said x is big and y is small. And I need to get my bigs up to 25. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 22, 24, 25. 25, 26 points. It's actually right about 26. Let's put it right about there. There's my big. Small needs to get up to 48. 5, 10, 15, 20, 25, 30, 35, 40, 45, 48. I'm going up by 5s. Connecting the dots. So where are the solutions to this? The solutions are all up here. I want to make more than this amount of money. Every point up here works. These are the points where they make enough money. These are the points where they don't make enough money. Everything up here works. All right, hey, thank you for watching, and I will see you later.